Hey guys, welcome to Pepcoding. So I hope you're doing fine. So today we are going to learn Sudoku solver using bit manipulation. So guys, we have already done this question in recursion, but let's do it again. So basically what my Sudoku says, there are three rules that if I want to fill a number here, that number should not exist in this particular column, this column. Okay, that means we would be having to check this cell of the columns. It should not be there in this particular row. So here we would check. It should not be here in this particular grid. This one. We'll check here. So we are clear that for columns and rows it is so easy that in ith cell we'll check that if it is there or not. In columns, in jth cell I'll check. But what about grid? How will I check in grid? Let's see. What should this index be? 0, 0. So how would I know that I am in 0th number grid? See, it's 0, 1, 2. How will my j travel in this box? In box 1. 0, 1, 2. And here, in rows, 0, 1, 2. 3 rows. Okay. So basically, my value of I, if I divide it by 3. If I divide 0, 1 or 2 by 3, I'll get 0. If I divide 0, 1, 2 by 3, I'll get 0. Similarly, if I come here, 3, 4, 5. Divide them by 3, you'll get 1, because 3 1s are 3. Then if you divide 4 or 5 also, then also you'll get 3 with remainder 1, 2 respectively. Similarly 6, 7, 8, divide them by 3. Here 3, 4, 5, divide them by 3. 6, 7, 8, divide them by 3. Okay, so just I by 3 and j by 3 would give me my particular position of grid, on which grid I am there, where I need to check. So what I was doing here was, here I was creating a array. My array size was 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, suppose I wanted to put 4 here, then I would go in my rows I, then in that I would go at 4th index and I'll check if there is true or false. If it is true, that means number is already there, then I would not enter the 4 there. If it is false, I would enter it. But this will require an extra array of size 9. Similarly here, 9 such arrays here, 9 such arrays here. I don't want that much extra space. Okay, so what I am going to do here is, just wait a sec. I'll simply put a number. A number has 32 bits. How many digits do I have? 9. So what I'll do, I'll simply take 10 bits. Last 10 bits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this is bit number. Let me write it with another color. 0, 1. This is so light. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Basically, I can say I have an array of 32 size. I am just using 10 bits. So, okay, if I want to check 4, then I'll go at 4th index in this bit. So, how will I go? Create a mask here. Mask by how? I'll simply left shift 1 4 times. I'll reach here. I'll do the AND operation. If answer comes 0, that means that bit was off. If answer come 1, suppose here was 1, that means if non-zero, something non-zero comes, that means that bit is already on. If it is on, that means 4 exists there, so I can't put 4 in my box. Okay, then I'll move to 5, 6, 7. I'll check for every value. Okay, so I hope I am clear that how my bits are being used instead of array. Basically, in array I have 10 indexes. In bits I have 32 bits. So the particular in that I was checking just the particular cell. Here I would check that ith bit. Okay, similarly it's quite similar to the array only. I'm just checking the bit. If it is on, that means true. If it is off, that means false. Rest everything is same. We'll do the recursion. So let's code this and understand by doing code. So first, if my array of ij is not equal to 0, that means number is already there. I don't need to enter my number again. So if it is not equal to 0, it is visited. I'll simply put a call. So recursive call would work here. And how it is going to be? Let's see. Array would be as it is, rows as it is, columns as it is, grid as it is. Now what about ing? Let's see. So guys, if I am in this part from 0 to 7, my j's range from 0 to 7, then I need to jump one step. Okay, but if I am at the last cell of my particular row, okay, that means my j is equal to 8. If j is till 7, that is j is less than 8, my j was getting +1. And if this condition fails, then I need to move. If I am here, then my next cell should be this one. Okay, so how am I going to go there? My j would become 0. Similarly here, my I was same, I was in same row, and if this conditions hit, j is equal to 8, my I would increase. I'll go in the next row, 0th column. See, next row, 0th column, else same row, another column. So just write that. If j is less than 8, I as it is, otherwise I plus 1. If j is less than 8, j plus 1, else 0. Okay. Let's put spaces to make our code look good and readable. Cool. Now what? In else part, what should we do? We'll try to put numbers from 1 to 9. So int nums equal to 1, nums less than equal to 9, nums plus plus. Okay. So what I need to check? If at the number that I am going to enter, if I can really enter it or not. So my rules were, it should not be there in my row, in my column, and in my grid. So I'll go to particular row. So I'll get it by row I, and I'll check by doing AND operation with mask. What was my mask? 1 left shift nums time is equal to 0. Put brackets, else it will give error because binary operation has least precedence. If this is true, then I can enter. And I also need to check same for columns and grid. So for grid, j by 3, I by 3, grid. For columns, j. Spelling of rows is wrong. You're right. If this is true, that my number is neither in my rows, my columns, and my grids, all the bits are off for that particular number. In that case, I'll put my number in the array. Then I'll simply make the same call. And when I return from the recursion, I'll remove my number and put 0 again. Okay, but one more thing that I need to do is I need to toggle. If this condition was false, if the bit were off, that means I need to on them, I need to toggle the bits. If the situation was false, see, I can do two things. Either I can put I can simply on them here and then off them here by doing OR operation for on and complements off operation for off. Else I can simply toggle them. I know that if I am coming in the if condition, these all were off. So if I toggle them, then it will on. And after when they are on, after recursion, when I return, I'll toggle them again and they will be off again. So simply toggle them by using XOR operation. Okay, with the mask, I'll toggle them. Okay, rows I. Same for columns. On them in columns also and grid also. I by 3, j by 3. Cool. And columns I. Sorry, columns j. Okay. Then toggle them again when you return, so that when they were on, now they will be off. Okay, my code won't run. Okay, why it is not running? Because I am not printing anything. So when do I need to print? Let's see that. So guys, if I am at this particular cell, that means my I is equal to 8 and j is equal to 8. If j is 8, this condition would hit. I'll move to I plus 1 and j 0. So now my I is equal to 9 and j is equal to 0. So if my I is equal to 9, that means I am here somewhere. If I am and 9 is my size of array. If my I is equal to array size, that means that I am out of the array. I am out of bound. That means my array was completely filled. When I moved here, that means my this cell was completely filled. So now I can simply print my answer. So for that I have already written display function. So simply call that display function. So if I equal to array dot size, call the display function and return. Cool. Let's run the code. It is successful, but we are not printing anything. Let's see why. Okay, if condition. Okay, 1 by 2. No, 1 by 3. Let's see now. Okay, answer comes. Let's submit it. So guys, I hope I am clear here. So if you like the video, please like, share and comment and subscribe to Pepcoding. Thanks for watching.